When I flip through the apps I have used most recently on my phone and ask which of these use location data, Uber, Google Maps, Instagram, Netflix, Amazon, Strava, Telegram. Location is a core primitive of the mobile web, but in Web 3, it's missing. We're building Astral to bring location to the decentralized web so developers can unlock a new generation of real-world, location-aware, decentralized apps. For the past 7 years, we've been exploring how to bring location data onto the decentralized web. But building location-aware dApps isn't easy. Geospatial data is messy. Spatial reference systems, projections, different formats. GPS can easily be spoofed, and spatial computation just isn't viable on-chain. I know this because over this exploration period, we worked on a dozen or so location-based Web3 apps from across the category: transport, gaming, sustainable finance, impact evaluation, and more. But in every case, we spent more time building the location layer than building the app itself. But it's 2025. Ethereum has evolved. We can do things we couldn't do before. So we've decided it's time to build the stack we always wished we'd had. Astral's products make it easy to build with location data in decentralized systems. There are a few things we've been working on. First, with our partners at the University of Maryland, we've been developing the location protocol, built on the Ethereum attestation service. Location attestations are the core data structure in the Astral ecosystem. Signed, structured records that describe place, time, and identity. Each location attestation includes information about geometry and is extensible to support timestamps, media attachments, and other attributes. Location attestations are flexible. Think GPS check-ins, a forest boundary, a delivery path. Like rows in a decentralized geospatial database, composable building blocks controlled by users and private when needed. But user coordinates alone can't be trusted. GPS is easily spoofed. When location data underpins a valuable transaction, or someone might have a good reason to lie, verifiability is critical. To solve this, we've built EigenLocation, an AVS built for Astral for verifying location proofs and running geospatial computation services. These two services are key for any location-based app. Together, they support things like point and polygon checks, geofencing, route tracking, shortest path computations, proximity matching, and so on. To show what's possible, we developed a demo app built on Astral and EigenLocation. It simulates a biodiversity impact evaluation workflow inspired by our friends at Gainforest and Hypercerts. Gainforest works with local communities to collect environmental impact data, including bioacoustic measurements captured with microphones on smartphones or IoT devices. Verification of this geolocated data is critical for impact funders to have confidence in project quality. The workflow looks like this. Gainforest chief scientist leads a team out to the project site. They collect ecological field recordings. They also record the device's location and supporting evidence from sensors, nearby devices, and people. That artifact is submitted to the EigenLocation AVS, which verifies the evidence and returns a signed location proof. With this verified location proof and the ecological data, the user registers their observation on EAS and IPFS. After the collection period, the chief scientist at Gainforest triggers a call to the Geospatial Computation Service, which verifies key facts and analyzes ecological data. The AVS attests modeled outputs, and everything can be visualized in the impact dashboard. Here's a demo of the AVS verification logic. You can see the location data getting parsed here in a second, and checks like point and polygon and identity verification just coming up. And here's a summary output. And here's a demo of the dashboard showing individual records and simulated outputs. We've got this demo project site in eastern Uganda. these points have been verified, these are pending, and these have been rejected because of some flaw in the submission. The purple dots denote AVS attested outputs, whereas these are user input details. And you can see here, if we look at record details, you can see the actual bioacoustic data as well as the recording on IPFS and the attestation data on EAS. This is on Sepolia. Astral unlocks geofenced apps and location-aware smart contract logic. With EigenLayer, our vision for Astral is finally possible. We can build what we couldn't have in 2018. A decentralized, economically accountable way to verify where someone was and reason about what that means. So, what can this unlock? Place-based experiences, quests in parks, local currencies, impact evaluation, ecological state monitoring, verified eyewitness accounts, infrastructure and supply chains like delivery, finance, compliance, enhanced wallet security, and all sorts of new governance patterns. Location is key to the mobile web, and we believe it should be native to the decentralized web as well. We're Astral. We're a small team building the geolocation layer for Web3, open, durable, and opt-in. What we're looking for: builders who want to use location as a primitive, grant support to fund development, advisors and partners to help us scale, an incubator, and validators who may want to secure the EigenLocation AVS. Join our Telegram and follow us on Twitter. We'll be sharing a link to the demo dashboard soon.